Welcome to ThirdEye Labs, where we make the unseen seen. Today, complex numbers are just rotations. Start on the number line. Multiplying by -1 flips this arrow to point the other way. A half turn. But what is half of a flip? A quarter turn. The arrow would lift off the line, and the line has nowhere for it to go. We need a second dimension. For 200 years, this broke mathematics. X squared equals -1. No real number works. Squaring always lands on a positive. Draw it. The curve floats clean above the axis and never crosses zero. The solution simply was not on the line. When someone finally wrote down a square root of -1, Descartes sneered and called it imaginary. The insult stuck. The idea, it turns out, was real all along. Stand the old number line up across the page. Then add a brand new one straight up, the imaginary axis. Together, the complex plane. A complex number is just a spot on it. 3 across, 2 up. We write that 3 plus 2i. The I only means this part is measured up the new axis. And just like a vector, draw the arrow from the origin out to it. A complex number is an arrow on this plane. Hold that picture. On a tightrope, you have one choice, forward or back. Step onto the floor and a whole new direction opens up. That second direction is all I is. Here is the whole secret. Put the arrow on 1, pointing right. Now multiply by I just once. It turns a perfect quarter turn to I. Multiply again, another quarter turn to -1. Again to -I, and once more all the way home to 1. 4 turns, 1 full circle. I is a quarter turn of the steering wheel. Do it twice, and you are pointing exactly backward. A U-turn. So why does I times I equal -1? Now it is obvious. I times I is 2 quarter turns in a row. 2 quarter turns make a half turn, and a half turn is exactly multiplying by -1. The arrow lands on -1. That is all I squared has ever meant. Adding is the easy one. Take 3 plus 1i. Add 1 plus 2i by sliding it on, tip to tail. Real parts add, imaginary parts add. 4 plus 3i. Adding just slides one arrow along the other. Now the magic one. Multiply 2 plus I by 1 plus I. The thing you multiply by has its own angle, 45 degrees, and its own length, √2. Watch the rule. The angles add, the arrow swings around by 45 degrees, and the lengths multiply, it stretches by √2. Turn, then zoom, and the algebra agrees. Multiply it out, remember I squared is -1, and you get 1 plus 3i. The exact arrow we landed on. The picture and the symbols are the same move. Multiplying spins one arrow by the other's angle and zooms it by the other's length. A turn and a zoom in a single step. One more move you will see everywhere. Take 3 plus 2i and flip its sign on the imaginary part. It reflects straight across the real axis. That mirror twin is called the conjugate. Same shadow across, opposite shadow up. Multiply a number by its conjugate and the imaginary parts cancel. You are left with a plain real number, the length, squared. That is how you turn a complex mess back into a size. Here is the reward for all that. Pick one arrow that turns a little and grows a little. Then keep multiplying by it. Each step turns a bit more and reaches a bit further. Do it over and over, and the tip traces a spiral. Turn plus grow, repeated, is the shape of every wave and every bit of growth in nature. There is a tidier way to name the arrow, not across and up, but length and angle. How long it is and which way it points. In this language, multiplying could not be simpler. Just add the angles and multiply the lengths. That is why this form exists. And here is the crown jewel. Send a dot around the unit circle. Its shadow across is the cosine, its shadow up is the sine. Euler bundled all of that into one symbol, e to the I theta. As theta grows, the dot just keeps riding around. Every rotation in a single tidy expression. E to the I theta is just a dot riding the unit circle. Theta is how far around it has gone. That one symbol packages every rotation. And this is not a museum piece. The Fourier transform wins a signal around a circle. Signal processing treats every wave as a spinning arrow. And inside today's language models, rotary embeddings literally rotate vectors to mark word order. So forget the word imaginary. It has fooled people for centuries into thinking these numbers are fake. I is not a fake number. It is a verb, a 90-degree turn. The cleanest rotation tool we have, doing real work everywhere from your phone's signal to its autocomplete. In one breath, a second axis turns the line into a plane. I is a quarter turn, so I squared is a half turn, -1. Adding slides, multiplying turns and zooms. E to the I theta packs every rotation into one symbol. Imaginary numbers are not fake. They are how machines spin. Next, Season 1 begins. Vectors stop being arrows and start carrying meaning, the language every AI model thinks in. Thanks for watching and keep exploring. Next time, vectors carry meaning. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.